All right, so let's look at example 4 here. We're going to write a system of equations as a matrix. Seems kind of weird to connect them. I think last year you all did some work with matrices in your geometry class, but probably not connecting them to systems of equations. So in this example, we're going to connect them, and actually in example 5, we're going to connect them as well. What you're going to find is in the next lesson, we're going to use the matrices to actually solve systems. So we'll take a look at that when we get to that. So let's first talk about what a matrix is. A matrix is just a rectangular array of numbers, well, values, but in this case will be numbers. So the way that works for matrices is if you group the coefficients and constants in a matrix, it's going to make a rectangle. The first thing you would need to do is get the equations into standard form. So notice how 3y equals 1 minus 2x ends up being 2x plus 3y equals 1, right? And then same thing with 4x equals 10 plus 2y, 4x minus 2y equals 10. Again, they need to be in standard form. Where you've got the x's lined up, the y's lined up, and then the constants on the other side of the equal sign. The coefficient matrix is a matrix of the coefficients. You've got 2, 3, 4, negative 2, 2, 3, 4, negative 2. All right, so that's that. The augmented matrix is going to also then include the constants. So you just take whatever the constants are, which in this case is 1 and 10, and then they become a separate part of the matrix. You have a little line there. The dimensions of this matrix, remember, R is always the number of rows, so there's 2 rows here, and then C is the number of columns, so 1, 2, 3. So this would be a 2 by 3 matrix. So in other words, this system of equations you can rewrite as this matrix. We're not doing anything else with that in this example, or actually in the next example. Next lesson, we're going to talk about how to turn the matrix into getting a solution to the system of equations. But for right now, we're just practicing turning an equation, or I'm sorry, a system of equations into an augmented matrix. Okay, let's look at the next one. Same idea, just with a 3 by 3. Okay, so the first thing you do is get everything in standard form. Although this basically was in standard form, notice how there was no z in the first equation, so now we have 0z there. You need the 0 placeholder because it needs to be a rectangle. All right, and then you just take the coefficients. X's are in the first column, Y's are in the second column, Z's are in the third column. The constants are the part after the line. So we're just going to do the same thing here. This is already in standard form, which is nice. If it wasn't in standard form, you had to get it in standard form. So you just take the coefficients and make a matrix out of it. 3, negative 1, negative 2, 7. You have a line there for the constants, and then 4 and 20 go there. That's it. Again, all we're doing right now is converting a system of equations to a matrix. The end result here will be we're going to use the matrix to solve the system. We're just not doing that yet. We're not there yet. What I will say is for 2 by 2s, there's pretty much no scenario where it would be efficient to solve using a matrix, right? Substitution or elimination is going to be faster. However, for a 3 by 3, kind of flips. The real value in this method, and what we're putting some time in right now for, is for the 3 by 3s. As you saw in example 3, solving a 3 by 3 is not simple. And by the way, those numbers kind of all worked out. Like 3 by 3s can get a lot messier given numbers that don't work out so nice. Um, so the real value in solving a 3 by 3 matrix, or in solving systems with matrices, is when it gets to be 3 by 3, or even if we're talking about like a 4 by 4 or something like that, um, matrices are going to be the way to go. So this is the reverse. We're going to take the matrix, and turn it into a system of equations. 0 there means there's no x. Let's just assume we're talking about x, y, and z. All right, so there's no x there, so it'd be then 2y plus 3z equals 4. Second equation is going to be 8x minus y minus 2z equals 5. Then the last equation is going to be 2x is no y plus z equals 9. All right. Let's look at the last example here.